Hi guys, welcome to the channel. So in previous videos we have already discussed about the electric dipole and the electric field at various points due to dipole. So now from this video we are going to discuss about the topic of torque. What is torque and how we can find out in which cases torque will be maximum or minimum. So first of all, what is torque? Suppose we are having two equal and opposite forces having same line of action. Now what do I mean by same line of action? Suppose we are having any charge. Suppose we are having this plus q charge here and we are having some force F acting on this point charge plus q in this direction. Okay, and a similar force with same magnitude F is working in this direction, just the opposite direction of this force, which means what, they have same line of action, that is this one, but both are working in opposite direction, both have same magnitude. In this case, what will happen with this plus q charge? Because one force is in this direction, other force is in this direction, both have same magnitude and are opposite to each other, then in that case this charge plus q will be in translational equilibrium. Now translational equilibrium is a very fancy term. It is just going to mean that because of these two equal and opposite forces, charge is not going to move anywhere. Okay, it is going to be in equilibrium position at this position itself. It's not going to move anywhere. It will be in translational equilibrium. This is the meaning of translational equilibrium. But this is the case when the line of action of these two forces, which are in opposite direction and same in magnitude, these forces have same line of action. This is the line of action. But what happens when this line of action changes but the forces remain as it is? That means the magnitude remains the same. Okay, both remain opposite in direction, but only the line of action changes. What do I mean by that? Now suppose another case in which we are having two charges. Suppose we are having minus q and plus q. We are having two charges separated by some small distance. This is basically a dipole, right? Separated by some small distance. Now again, forces are acting on them. One force is acting in this direction. This is force F. Another force is acting in this direction. This is also F. Both have same magnitude, opposite direction, but their line of action is different. This is the line of action for this one and this is the line of action for this one, but both are same in magnitude and opposite in direction. Now what happens? Now these forces are acting, suppose these forces are acting on these charges because of the presence of some sort of electric field. So electric field will be in this direction, right? Electric field will be like this. Suppose these forces are due to this electric field E. So force on plus q charge will be in the direction of field and on minus q charge will be opposite to the direction of this field. Okay. Now we already know the direction of forces on plus q and minus q charges respectively. Now these two forces are equal in magnitude and opposite in direction. It will rotate this dipole, which is called as spinning, due to this force and due to this force. This dipole will start to spin like this, right? Due to this force it will move in this direction and due to this force it will move in this direction. It will start to spin, right? This spinning, This type of force due to which spinning happens, this is known as torque, right? Two equal and opposite forces having different lines of action, right, which are being opposed on these charges, or you can say on this dipole, causes spinning motion of this dipole. These type of forces are known as torque, right? Now I hope what is torque is clear, right? Now we define torque like this. This is known as tau, and tau is the symbol for torque. In mathematical terms, if we want to define torque, then that is force multiplied by perpendicular distance. This is the formula for torque. Now we will discuss about this formula as well. Now again, suppose we are having this type of a dipole on which forces are acting, right? Now this is point O, which is the center of this dipole. Suppose this distance and this distance, these are A, right? These two distances are A and A. That means overall distance between minus q and plus q is 2A. Now take horizontal line from this point O. This is a horizontal line from this center O, and take a perpendicular line from this point plus q on this horizontal line. Okay, I'm designating this point as A and this point as B. Okay, now this point is suppose C. This AC distance is suppose X, right? This AC distance is X, and this we have defined, this OA distance is A. Suppose this triangle, I'm taking this triangle OAC. In this triangle, what you will see, if I want to define, if this is angle theta, right, angle AOC, this is angle theta, then if we want to define sine theta here, then what will be sine theta? Sine theta will be x divided by A, right? Perpendicular by hypotenuse. So perpendicular by hypotenuse will be sine theta. From here we can get the value of x, that is equals to A sine theta, right? This value we will use later on. Now in this diagram, what you can see is we have seen two torques, one in this direction and one in this direction. I'm naming them as tau 1 and tau 2. These are the two torques. So net torque acting on this dipole, that will be summation of these two torques, tau 1 plus tau 2. I'm just going to substitute the formula of torque here and here. So torque will be force into perpendicular distance for the first case plus force into perpendicular distance for the second case. Now consider the first case. Now what are these two cases? First case is for plus q charge and second case is for minus q charge. So first of all we are taking the case of plus q charge. Similar will be the case of minus q charge. So for plus q charge, what is force? Force is F. And what is perpendicular distance? Perpendicular distance is what? Distance of this point A, that is where plus q charge is located, to point O. This perpendicular distance from here up till here, this x is the perpendicular distance. That is why I have defined this particular distance. So this will be the perpendicular distance, right? This x will be the perpendicular distance that we have found, that is A sine theta. So force will be F and perpendicular distance will be A sine theta. Similar will be the case for the minus q charge, right? That will also be, that perpendicular distance will also be a sine theta, because here also if we make a triangle, right, then here we will be having some sort of angle theta and perpendicular distance x, just like this one. So perpendicular distance will be same. So for first case, force will be F multiplied by perpendicular distance, that is x. X is a sine theta, plus for second case, that is for minus q charge also, we will be having force F multiplied by a sine theta. So torque will be equal to 2 times of F a sine theta. Now we know the formula for F. F is equals to what? Q into E. So tau will be equal to 2 q E a sine theta. We can write this as E into Q into 2a into sine theta, right? Now Q into 2a is what? That is P. So tau will be equal to PE sine theta. This is the formula for tau, that is torque. Or you can, or if you want to define the direction of torque, in which direction torque is applied, so that will be equal to P cross E. How I know? Because when you do P cross E, direction of P is what? Direction of P is from minus Q to plus Q, like this. This is the direction of P and this is the direction of E, right? This is the direction of E. So when you do P cross E, then it moves P cross E. It moves clockwise, right? It moves clockwise like this. So torque will be P cross E. I hope you know how to find out P cross E, right? P is in this direction, E is in this direction. So P cross E will be moving in clockwise direction. So torque will be P cross E, right? So this is the magnitude of torque and this is how you can find out the direction of torque. So in the next video, we are going to discuss how to find tau max and tau minimum. That is, in which of the cases, in case of these dipoles, in which type of orientation torque will be maximum and which type of orientation torque will be minimum. So I hope this video was helpful for you. So far that's it for this video. Thank you so much for watching.